So, hi, my name is Kalpana Ravi, and this is the project I built for this course, CS CIE 90. In this project, I built a real-time streaming analytics platform on AWS using the Jira product sales dataset. The goal of the system is to simulate continuous retail sales events and process them in real time while also storing all raw data for historical analysis. The architecture uses Amazon Kinesis for streaming ingestions and AWS Lambda for real-time processing, Amazon DynamoDB for low latency aggregated metrics, and Amazon S3 and with AWS Glue and Amazon Athena for a SQL-based historical analytics. On top of that, I also built the dashboard using the Amazon QuickSight. Um, this project demonstrates how modern event-driven architectures can support both real-time insights such as best selling categories and promotion impact and deeper analytical queries over time. Um, in the next following section, I will walk through the full detailed steps of how I built this project, and I'll demonstrate of this system end to end. After the prerequisites setup is done, the very first step in my project is creating the S3 bucket. This S3 bucket will act as the raw event data lake and process the JSON records through the streaming from the Jira sales data set. So for that, I'm going to create the S3 bucket here and name the my S3 bucket as the course name, followed by the project name, followed by my initials, and I leave the remaining default settings as it is, and we don't want this bucket to be public, and all the versioning and everything, and I kept it default encryption. Everything is fine, so I create the bucket. So in this bucket, I'm not going to upload any um, data files or the test files. As I mentioned before, it will stream from the that that's .csv file, the sales data .csv file that is a real-time ingestion, act as a real-time ingestion, and then we build the real-time analytics on top of that using the Lambda and the Kinesis and all those services, and then we will build the QuickSight dashboard on top of it. Okay, so next I'm going to create a Kinesis data stream, which will be used as to ingest the real-time Jira sales events. This Kinesis will be on-demand stream. Okay, so let's go and create the data stream. So, and I will put stream name is Jira sales stream. And I can put the capacity is on demand, and we'll leave the remaining settings as default. As you can see, the maximum record size is 1024 kilobytes. You cannot increase this size. This is a AWS hard setting, and the data streaming settings will keep default. And here the data retention period is 24 hours. Will fine for this project, and we'll keep the server side encryption as it is. This is not a production project. It's just educational point of view. We're creating this. So we'll keep the encryption disabled as it is, and we'll leave the default settings. And let's create the data stream. And it takes 30 to 60 seconds to make it active. Um, okay, looks like this is successfully created. And next, we are going to create, in the next step, I'll create the Python producer to send the real-time sales events into this stream. So now I'm going to create the tables under the DynamoDB. And these tables serve as a real-time aggregation layer, storing the pre-computed metrics to so that a dashboard or the APIs can retrieve these insights without querying the raw data. So I chose three business use cases I'm going to create three tables. Each will serve with different business use case purpose. Um, it is metrics by Jara, metrics by category, which will serve the which product categories are selling the most based on as of that point of the time, and how the seasonal Jara metrics by the season. That table calculates or gives the information of the how the seasonal products are performing today compared to the yesterday or compared to the previous years or something like that. And the table is Jara metrics by Premo. Does this table really help the does the promotions really help increase the sales value volume or not? These are the three business cases I chose for this project. Additional tables or additional scenarios we can add if needed later. But so um, the category, season, and promotion are the most common ways to analyze the performance of the any um, uh, you know these things. So let's create the tables. Mm, so let's click on the create table, and the first one is Jara sales by category. Mm, um, the category is string quotation name. And we leave the remaining fields as default, and that's it. We'll create the Jara matrix by category, the first table. Let's create the next table, um, which is Jara matrix by season. Automated spell season. Here's a season. Here's the category is string. Um, and no sortie. We'll leave the default setting as it is, and we'll create the second table, and then we'll create another table, which is promotion parametrics by promo. And we'll have the promo flag as the string. String, and we'll leave the remaining values. The promo flag can be yes or no, those kind of values. So we'll leave the remaining values default settings, and I'll create the tables. Okay. So now I'm going to create the IAM role. This role will required for the AWS Lambda processing. So a Lambda does not automatically have the permission to access to the AWS services. So since it is a managed service, so what I'm going to create, I'm going to create a role and which I will give the access to attach the policies. The use case type is the Lambda, but then the attach the policies as Amazon Kinesis read-only access, which will allows the Lambda to read streaming data from Kinesis, and S3 full access. It allows Lambda to write raw events to S3, and then I'll also attach the policies as DynamoDB full access, which will allows Lambda to write the aggregates to the DynamoDB, and then finally the uh, Lambda execution role, which will log the execution details to the CloudWatch. Okay, so let's create the role. Uh, the role, create a role, and the role type is the AWS service. And use case is the Lambda. And then next, here we'll attach the permission policies, right? So um, which are Amazon. Uh, Amazon can access, read only access. Okay. So, read only access. Actually, I want to attach one more, three more actually. So then Amazon, um, that's three, um, full access, and Then folder system. And then the Amazon. um, Dynamo TV. Um, Access. And next is AWS. Um, and um, and, basic execution role. Okay. Um, the role name is Java Lambda stream role, and we create that one. And then we have all these things. Um, yeah, so, okay, so we create the role. Yeah. Just want to make sure the role which we created has access to that, all those things. So this is the role we created, and that's what it is. Of policies attached. Okay. So I'm going to create the Lambda function now, and this Lambda function is a kind of a brain of the system, what I'm trying to build. It does the real-time processing. It really receives the live sales events from Kinesis and stores the raw data and updates the real-time metrics in the dashboard and all those places. So what it does is it reads the streaming events, parses and transforms the data, and decodes that information, and stores the raw events into the S3 and updates the aggregated matrix in the DynamoDB. So part of this function, we also uh, have the environmental variables so that we can avoid coding the, and it is easy to configurable, right? So where if something needs to change, the name changing and all those things, environmental variable will help. It is a clean way of doing the code. So then after that, we are going to set up the Kinesis trigger, and which will um, trigger whenever the uh, and it sets the batch of the 100 events, and it reads the process those uh, records of 100 records for each batch. Okay, so let's create. So my function name is there one thing, yeah, Jara Stream Processor. The function name is the Jara Stream Processor, and copy this basic. And the runtime is Python, and we will leave the durable execution off. This durable execution is only for the long running and multi-step workflows required. We don't have anything in this project, so we'll leave it off. And then we select the permissions under the, we'll leave the architecture 86 underscore 64. This is most compatible and flexible ones. Under the permissions, we'll use previously we created an IAM role for these purposes. So we'll select existing role, which will be Java Lambda stream role. And then in the additional configurations, we leave the everything as it is, except um, no, we additional configuration we leave will consider the default, not here in the when it is creating the trigger, maybe uh, will add retries or something. But for now, the we'll leave the default and we'll create the function. Okay. Now, under the configuration, um, under the environmental variables, as discussed, we're going to create. So, we'll create four environmental variables, S3 bucket, and then three tables, the DynamoDB tables, right? So these are the names. Yeah. Rocket. And this is the value of my S3 bucket name. And the next one is related to the DynamoDB tables. Um, Parameters category. Mhm. Okay, so we save these variables. So We're good there. Now we're going to create the trigger, right? So we're going to add the trigger and right. So does what this trigger will does is this trigger will uh, tell what Lambda needs to do or the or when to run the Lambda, and it automatically invokes the Lambda when new records arrive, handles the scaling and batching, and in this trigger we are going to put the batch size to 100, and uh, I think for this project, for this data size, um, considering uh, the Kinesis and Lambda maximum record size is 1 MB, and processing point of view and the failures and retries point of view, though considering based on those calculations, came up with 100 is the safest baseline here. If we need to change, we can add after, we can scale up after the measurement. But if we increase the batch size, then the timeout has to be increased. So uh, with that with that things in consideration, let's create the trigger. Instances. So the stream is we already created the Kinesis stream, sales stream, and we activate the trigger, and we have the batch size, and our starting position is 100. Additional settings is we leave everything as it is. Um, Then this one, except the report batch item failures, will enable this one. If something partially fails, then it will come to there. Okay, so we'll add the trigger here on this, and right. Okay, so now we'll create the function, the code to the function. What this Lambda function does is, as I mentioned, it is a real-time processing layer for the Zara sales analytic pipeline. It triggered by the this Kinesis, and what does it does is it process incoming sales events in batches. For each event, the function decodes the data, calculates the revenue by multiplying by price and sales value, and enriches the record with a processing timestamp. These enriched events will be stored into the Amazon S3 bucket, and using partitions, and also this function updates three DynamoDB tables to maintain the real-time aggregates, product category, season, and promotion flag. So what this will help is at the end, this real-time dashboard and analytics, uh, uh, and invalid records will be skipped without interrupting the stream. So let me, I already have written the code and tested in my local. So, make sure that code syntax wise and everything works correctly. So I'm going to copy and paste that code here and deploy that code. So Excuse me. Um, we have that, and we deploy this code. Um, we can. um, so let's deploy this. Okay, so it deployed successfully, and we'll test this pipeline using the when we created the producer and process the real-time events. Okay. Okay. So now I'm at the creating the producer code. So what does this producer does? And this producer is runs in our local system, and it reads the information from the Jara underscore sales underscore EDA dot CSV file, and stream gives the information to the Kinesis, and from there Kinesis to Lambda, Lambda to demo tables, right? That's the flow. So here I struggled, stuck or went back and forth a lot of times on this code here. So initially, what I did was in this producer code, I simply read the CSV file and I stream it to the Kinesis stream I created, and process it. It worked fine. But then later, I realized that when I want to rerun my producer again, so it's simply adding the counts or the aggregations on top of the existing. There is no new data. It's already existing data, but it's keep adding. So that is not a right way of representing the dashboard's information or any other information in a view. So I want to eliminate duplicates, and I also want to replicate the system like a real time, like practical way, right? So okay, I read the information, I process it, and when the new event comes, I want to process that or existing event updated or existing event deleted or something like that. Any modification happens to that particular product or any for that event, I want to make that change and reflect that immediately. So that's the system I want to build. That's why it went back and forth on the ideas. So what I did was the flow point of view. So I initially I was reading directly from the producer directly. So I changed the approach. What I did was instead of reading from the CSV, so I put the CSV file into the local SQL server database, which is I created Jara underscore sales, and then I injected the data through the Python code, the CSV file. and inject that data into the CSV file, which is the first code for this is load underscore C to the SQL. So it will load the table into the table, and then once that is done, then I will my producer from underscore SQL takes the information from the table. um, Basically, what it does is it reads the information CSV into the SQL. The product ID is unique for this, all of this, and the payload is a kind of a JSON information because Lambda and Lambda possesses this JSON. We protect the payload in the JSON, which has all the category information, type of sales volume, pricing information, and all that information in that JSON format. So in that column, particular column. So I'll show you in a minute. So um, and then once that's done, then what happens is my producer from underscore SQL reads that information from that table and sends that JSON to the Kinesis through the Kinesis stream to the Lambda, and the Lambda using the triggers and the function code it, updates to the dynamic. And the last Python was for this in the producer point of view. So upsert or the deletion or anything. So later, what I was okay, you read the CSV file and we processed all that. We want to change any of the existing product ID or want to add the new product ID information. So this Python file will does that. It asks the users interactively what product ID or you want to change or what information you want to update and all those things, and updates back to the table and the producer. Then we run again the producer, and the producer reads the information. If that event was, it maintains the table, maintains the information was sent previously or not. So based on the status, it will identify if it is a new or outdated and all those things, and then it reads back and send it back to the Lambda and DynamoDB. So here is um, demo I want to show. So these are there are tables. The first one is the devices which is related to the homework 12. So in my previous section, I explained what Zara function looks like and all those things, right? So here my has the code and all the Lambda function and is there already. So now this is my Dynamo tables, which doesn't have anything information right now, and yeah, none of them doesn't have any information. So now what we will do is, as I mentioned, we'll run the load that CSV file. So this is my SQL server. You have Zara sales, and I have Zara outbox, and see, um, let's execute now at this point. So I previously ran and did the testing all these things. So now what I will do is I will do the truncate the table, and I will execute from the start. Okay. So now the truncation happened, and there's no entries, right? So so now Dynamo table doesn't have any information, and this SQL table doesn't have any information. So now this is the Python code. First one is the loading CSV not SQL. So we'll execute this, and see. The CSV has 20,252 records and loading all those records into the table, first step. So now if I go back and execute that table, see all the product ID is taken from the CSV file, which is a unique ID, and the remaining information is in the JSON format we created in the using that Python file, and the status is new. That means it has not been sent, and the remainings are if it is a failed, then we can update this attempted, all those things. That's the first step. Okay. So the next one is so this is my producer. What it does is now it reads that information from that SQL table and sends that JSON file in the form of batches, which is a 500. See, it is my connected to the Java SQL server and all that. And then this is the. So now I execute this. So it starts sending the 500 and how many total sending. As you can see immediately, if we come back into the Dynamo tables, um, the see this stream, the Kinesis stream through the Kinesis stream and the Lambda function code, it is uh, creating the aggregation in the Dynamo tables, basically. So this is a kind of a composite table. We have the category and then country combined here, and then this table will help whether the sales has been helped or not through the promotion or not, which I explained in the earlier. So this is about the seasons, all those things, and this is what category those things, men and women. Okay. All right, so this will keep updating because though producer sends the records into the batches of 500 for every, which will take to process all 50,000 records 1 minute or 1 to 2 minutes. But then the this lambda function takes does the 100 records, so it takes a couple of minutes to process all of those 20,000 records. Meanwhile, so if you go back to this Python thing, it says it is already sent, no failed ones. It sent all the records to the Lambda. Okay, so the Lambda is keep processing. While it does that, so now we saw the Dynamo tables, and then if you look into the monitors, right? So in the Lambda function, uh, keep there is some action going on here, and then we can go and look into the CloudWatch logs also here. It's taking the time to update. Okay, so if you open up, I think it is the UTC time it is following. So it's processing, right? This information is keep on processing, and it is start requested and is processed. It is not skipped. You can look into the S3 bucket, the log and raw events information. So now we go to the S3 bucket and um, see raw and events. So it is format is different. Let's go into the hour four. So hopefully this one is so these are the JSON files. It is writing and putting that information back there. Okay. So that's so while that is done, so then I want to show the how the upsert process also works. So now eh, so now you go back to the SQL. What it does is if I execute, it says all of them are sent and the attempted count is previously. And so basically, if I do this, there won't be any records, right? All of them are sent at this point of the time. So we'll take one of the IDs and we're going to update and reprocess the producer, see how that works. Okay. So we'll take the first ID. Um, Go here. This is the upsert code or delete product category. So I execute this. So it will do is what it will this code will do is when I enter the product ID, it will check whether that product ID exists in the table. If the product ID exists, it will ask whether it is a deletion or update. If doesn't exist, it will ask if you want this an entry, new entry with this product ID. That's what it's going to do. So I am saying that do you want to delete? I said no, I don't want to delete. So, so we'll keep it as is. Yeah. So current it is Ottoman. So I want to change it to winter. And now I want to change it to Y. We'll keep as same as it is. We'll do it India. And we'll see 30. And then volume, I would say 450. Okay. So it did, right? So now what it does, this code created an entry into this table with new information. So now if I go back and execute this, now I have this one record with the new information, all those things. So in the now I have to run the producer. The producer sends old and new, but the Lambda function also in the Lambda function it looks for the uh, old event information and the new event information and updates the counts accordingly. So that is a simulating the real world scenarios. So now I go back to here. So now we have this, and then we'll run the producer again. So this time it will only do one record. So producer one, sent one. So it just took that one new record and sent it to uh, the that to the Dynamo tables aggregation information. So that's what it is. Next, we're going to build some real analytics and dashboards on top of this. Thank you. So now I'm going to create the, or I'm going to utilize the services, Athena, to put the, yeah, I mean, real analytics in the streaming data in the S3 bucket. So what I did was the uh, the database, Jara and analytics database. This database will act as a namescape, name of Athena, and it organizes the data and brings the S3 data into the relational. format. Then I also created the crawler, which is Jara raw events crawler. So basically, it will automatically it have. If you look into this, I so it will read the data and it detects the column names and the data types and file format, and it creates a table in the mm, in on the under that database which we created in the Glue database data catalog. Okay. Um, so then then once that is done, I it already did. So basically, if I go to the query, basically it created this table. Now I'm going to now go to the Athena query. So I'm going to set up the different queries based on the data, what I know. I did created have some queries in place. So so I'm going to run those queries against this Athena in the Athena query editor. Oh, by the way, so in the Athena, initially when I was running this primary work group was turned off, and then I edited this work group to make it more customizable and to save the results into the Athena. So Athena results in the place. So now I can able to run the queries. So what I'm looking is these insights is one is revenue by the category, and how much revenue it created with the help of promotions or non-promotions, and also here revenue by season wise, how much revenue it is generated, and then this one is uh, which what is the top material um, in the for that revenue, So as you see here, uh, ran this, and I can run one more time. So here here we have the category. To see this data, probably it has previously it created errors. That's why it is unknown and process it created. But generally, the cloud is the only category when I see the data. So um, then Premo versus non-Premo. Yeah, basically we have all this Y and N and no, yes, everything exists. So we have number of orders, and it will what is the revenue, how much revenue it is generated, and so basically it will give the different insights without creating any servers or anything. It's just that's the beauty and that's the power of this data lake, right? You just invest and then query it against that data lake. So, okay. So in this, I'm going to create the lightweight matrix API to expose the real-time aggregates previously stored in the DynamoDB. So I already created that Lambda function Zara matrix API, as you can see here. And this function does not process the streaming the data. Instead, it simply reads pre-aggregated metrics from the DynamoDB tables. So I have the code here, and if you look into the configurations, we have the environmental variables also I created. So uh, then once this function is created, so I emptied the DynamoDB tables information to showcase the how the real time analytics can be shown seen in the browser, right? So I also created the API. So it is a HTTP based API, and this will connect to the Lambda function I just created, and we have in this three get methods based on the season, category, and promo. And we have this CORS is course is also enabled with the different information. So now this is the testing time. So let me run the producer. The producer which pushes the data to the DynamoDB using the first Lambda function. And this particular Lambda function reads the information, what is it is creating in the DynamoDB table. So let me do that. So I'll run the load. Okay. And the next step is so, so it slowly start creating the DynamoDB tables. If you look into the explore this items, explore the items. So see, let's keep pushing the information. So if we keep refreshing, these numbers keep increasing. So this, while this is creating that we can do several things. So you can, I showed we can go to the um, using the Ethna and Glue, and we can query the data lake. But here I am going to do the analytics using that API gateway I created, and using that Lambda function. So if I go to the API gateway, um, so as I showed, this has three methods, and so my invoke URL is this. So I'm going to call that those methods using that invoke. So obviously now what it will these in the browser, it will going to keep on going to increase the values when we keep refreshing. So let's say genes, see the genes previously 162, it got increased to 182. So same thing, let's see that. The DB backend, it is refreshing. So see, keep on refreshing, the string became 423 to 433, and the values keep increasing. So then you have another one is the um, promo. Um, so you have only two values here. So these values also keep increasing. So this is really helpful, real-time analytics, wherever it is built and used, you can really see the where exactly the issues. You can identify where it is already performing well. All that information can be done, find out can be found out through the real time. So this is the final step of the project. I built the dashboards using the Amazon QuickSight. Initially, we have to set up the Amazon QuickSight account and all those things. Once you have set up, I created the data sets. Um, uh, Before you creating the data set, you have to make sure the permissions to the S3 bucket and Amazon Athena has a valid permissions, right access to those logs and all those things. So once that is done, you have to create a data set. Um, so I created a, um, data set here for the dashboard purposes, and the data set, the source type is first, the data source type is Athena, and then you have to select the database and then the tables, and uh, then you have to click the visualize. Once you are in that position, so what happens is you will be directed to here. So what I did is I created um, dashboards. One is horizontal, vertical, different dashboards are available here in um, website. So I created um, business cases and which provides the insights into the Jara's business, right? So the first one I created the top product categories by the sales volume. Then the next one is a vertical chart, which will give the how much revenue the top products, the top products which has whatever the revenue has, and then business case is revenue created, how much revenue is created by the season. The fourth one is the map. This is my favorite. It is not like a tableau or anything, but it is basic thing, right? So I did here sales revenue by the how much sales and how many associated how much revenue it is created in each country. Some kind of but so I created what available. So if you look if you go for a country and it tells how much in China, what sales volume, what is the revenue generated for that. Similarly, in India, you have this, and the last one is uh, the insight it will give. The last chart is uh, help to decrease revenue or decrease the revenue. So this dashboard I created and to it really understand the business more, where the gaps are, and where to improve, where the business is doing well.